All right, welcome back for season two of our anaerobic digestion webinar series. One of the things that you all said you wanted last year was more case studies and discussion of companies implementing anaerobic digesters. Ben and Scott from Burns and McDowell were kind enough to get us started on this webinar series this year, talking about some of the work they've been doing in anaerobic digestion systems for quite a few years now and implementing systems. So with that, excited to all have you here and especially excited to have our guest presenters today joining us. So Scott and Ben.
Thanks, Dan. Yeah, Scott Martin. I've been with Burns and Mac for 18 years. I've been doing biogas projects for about 20 years. So happy to be here today, and looking forward to presenting. Ben?
I'm Ben Sheff. I've been with Burns and McDonnell for almost 2 years now, but I've been in the biogas industry for going on 18 years. Anywhere from design, engineering, on-site construction, management, operations, the whole kit and caboodle. So very happy to present for everybody here.
Yeah, and this is the agenda for today. So we're going to spend the first half of the presentation going through anaerobic digestion, and then we'll talk about biogas use, conditions, renewable natural gas market drivers, and overall some just general project development considerations. So with that, I'll hand it over to Ben.
So first off, I'm going to take this here. This is something that I've actually been doing a lot of work with the American Biogas Council, talking about the potential for biogas projects, right? I mean, for anybody driving around, right, you see a landfill, you see that flare going up, right? That's biogas. I mean, that's something that can be used. We have a lot of food waste, right? That you could say, hey, put it in the landfill, right? It's going to digest and make biogas as well. That's great, but what about the nutrients that are now lost to that landfill? So this is kind of the thing that we're looking at across the whole US. You see there's a lot of potential for new systems. And whereas like a lot of the big dairy farms, right, have kind of been picked over and used, and projects have been done with them, a lot of the smaller ones, technology is coming along. We're starting to get smaller systems that can handle smaller flows. And we're really starting to implement more and more systems across the US, be it for food waste, be it for dairies, be it landfill work. So there's unlimited potential here. And it's nice to see that it just continues to grow. I was lucky enough that early in my career, I spent a lot of time in Europe commissioning digesters, both in the UK and in Germany. And it was amazing seeing what a fully developed biogas use in a country it was like. And I definitely see we can get there. We just have to continue to push forward. Next slide, please. So I'm going to talk over here some different basics of digesters. Some of the important things to look at, like when you're doing a site selection, like from direct development. And this is something where multiple times in my career, I've had to be the bearer of bad news to say, hey, listen, there's not a project here. And it just comes down to some basic criteria here that I'm going to go through. And we'll touch on it more as we go through the presentation. But feedstock availability and compatibility. This is big. I run into so many sites that love to do what I call the field of dreams approach. They build the site thinking, hey, I'm in an industrial area. There's a lot of food processors here. There's a brewery down the street. Like, I'm gonna get waste. And then they get there and nobody wants to give it to them. Either the tipping charges are too much, or they already have, like, for example, the brewer, a lot of their waste mash can go to farmers to feed cows and be mixed in with their feed. So they're not going to want to pay a tipping fee if they're, say, getting paid by a farmer. So there's things to keep in mind about that. Also, compatibility, right? Do you have a system? Like, I was running a food waste digester down in North Carolina, and very inconsistent feed waste. Like, some days you'd get a couple pallets of bologna, other days you'd get tons and tons and tons of restaurant waste, or not restaurant, grocery store waste that all had to be depackaged. And depackaging comes with its own issues, and things like that. So this is all stuff that needs to be thought of before you even pick the site. Is where are you going to get this food? How much is going to come in? And then another big part of that is, and it kind of goes with the next point here with manure and digestate management, is okay, so you've got the feedstock, but what do you do with what's left over? There's going to be digestate. It doesn't just disappear once it goes in the tanks. So that's something that you got to keep in mind. How is that going to be disposed of? Do you have a dairy that's going to take it back? Do you have a wastewater treatment plant that you're going to do some basic treatment to and then discharge? So these are all things to keep in mind. Land availability and restrictions, another big one. I know a facility that was out in the East Coast. They ended up building on a small plot of land in an industrial area. They thought, hey, we're good, we're set. And within a couple of years, that became a huge problem because they just outgrew the lot and they don't have the space for the trucks and things to come in and turn around. So these are things you want to look at. Any restrictions in that area too, anything to do with, say, you have waterways. Like I was at one site where there was a waterway that actually went through the middle of the site, which why it got built, that was before my time, but that was always a problem because now, right, if you had a spill, it's going to go right into that waterway. Utility availability. This is big if you're looking out west. One facility I worked at was out about an hour and a half drive off of Interstate 15 going through Utah, where you were just out in the flats. There was nothing out there. And, hey, were you going to get three-phase power? You need that. You need that for running your equipment. I know one of their issues came with heating. They needed propane, and it became very expensive to get it moved out there because it had to be trucked. So things to keep in mind. And then environmental and permitting considerations, as I talked about with that stream, or maybe of wetlands nearby or anything like that. These are all things that you want to take into account when you're selecting a site. Next slide, please. So this is a little teaser here. This is a deck that we put together a couple projects ago that basically looks at some of the variability on manure, right? So if we have, and this is where it becomes really important to know your manure, like if you're doing a dairy digester, know what you're going to be getting. So say it's a flush managed sand bedded dairy. So that sand has got to come back out, right? Because if that sand gets through the system, one, it's going to damage your equipment, and two, when it's held in the emulsion of the manure, and once you heat that up, it starts to break down that emulsion and all that sliminess of the manure. That breaks down, and that sand drops right out. And guess where it encounters that heat to do that? In the digester tank. So these are things to keep in mind with sand, but you got to remove that sand. So by doing that, you're going to end up with a product that's, because right, you have to dilute it enough to get the sand to settle out depending on the particle size. So, if you have a very fine sand, it's going to take some pretty intense dilution, which is going to take you down to that 1 to 3% TS. And that's when right now you got to think about, how am I going to do this? Because if I do a tank, a big CSTR, which we'll talk about in a little bit, that's going to have a massive volume because that TS is so low. Whereas as you go up the scale and say you have somebody that's scraping the manure straight off the lanes, it's going right into, or maybe vacuuming it, and they're using fiber bedding, something that can go right back into the digester, then that gives you a lot thicker manure to deal with. But now you have to make sure, okay, do I have pumps that can handle that? Do I have a digester style selected that can handle that thicker material? And then we talk about on the same deck about what that means for treating that effluent or that digestate from the digester. How are you going to get phosphorus out of it? Like if you're dealing with somewhere that's very environmentally sensitive to phosphorus, or what have you. So this is just a little teaser on some of the things that go into when you select a site and what technology you're going to use, and just how important it is to not just go. I had one project in Utah. I'll never forget this. I show up and they're, oh, we have thousands of cows. Look at them all out there. And I get out there and they're all open lot. In open lot, you're not going to collect but the feed lane, which is like 35% of the total manure there. So that already shoots it down. Then you're out open to air. So the manure is open to heat and wind, rain, dilution. It can sink into the ground. You're not going to be able to collect it if it's not on concrete because it's going to sink into the ground. So these were all things that just, when you're doing a project, especially manure based, these are all things you have to keep in mind. So next slide. Here's an example of a covered lagoon digester. Now, this would be something that would be in regards to the past slide, but what we're talking about for the lower TS, this would be a perfect fit because this is low maintenance. You can put some simple mixing in it. It's easy to get volume, process volume with this. This is an example of a location in Western Michigan. It's a meat processing plant, and that's the lagoon there that they've had going for, I think, over 30 years now that this facility has been running, has been designed. It's a peaking facility. So basically, as that dome perks up due to gas, they then run at night, and they have 4 CHP units, combined heat and power. So basically, diesel engines that have been converted to run on biogas that create back to the grid. So next slide. So this is CSTR, continuous stir tank reactor. These are one of the most common ones you'll see. They're popular for manure, food waste. Really most substrates that are, so anywhere between up to about 12% solids usually is pumpable, especially for manure. So we got a picture of a facility there on the left that's a manure-based facility. The right is a facility at Michigan State University. And then in the bottom there, that's an actual look inside of a CSTR. So this is not obviously the whole inside, but you can see those rings there. Those are your heat loops. So those are what's heating the manure, in this case, manure. And then that prop is a hydraulic mixer that you can move up and down to break up any floating layers or anything that might need so that you're getting that continuous stirring action. Next slide. Okay. Next would be a high solids, like a batch process. So this is a facility that does very high solids. And what they do is you can see in the picture to the left, those bay doors there. Each one of those has a cell that looks like the top right. And what they do is they actually use that front loader in the middle picture and they'll mix the piles of organics together and then load it into the cell. And then they remove the oxygen from the cell. Then they sprinkle on leachate from a previous, or not leachate, sorry, digestate from a previous batch. And then that allows the organics to be broken down and create biogas. Then the biogas is removed from the cell after I believe they were doing 30-day retention time before then they would then take the front loader and scoop it out. So that's something you don't see as often, but definitely if you're dealing with a high solids content, this would be the way to go. Next slide, please. Next would be a plug flow. Now, these are very, very popular in a lot of dairies. You'll see them. In fact, that's the picture on the left is a dairy facility. On the right is at a university that they were taking food waste in from their mess halls and some dairy waste in from their ag program. And plug flow basically is set up in a way that it goes like a giant horseshoe. You'll feed into the pit, and then it just, as you feed in, it slowly moves its way through that horseshoe until it makes it to the exit side. And that's usually designed for retention time of around 14 to 21 days, depending on what you're digesting. And then gas is collected via either on the left, it's just a solid top, so there's very little headspace, so you kind of have to use what's made, which can be kind of tricky. And on the right is using a dome for gas storage. Next slide, please. This would be a good example of some site selection matrices that we've used in the past on different projects. This was actually in Wisconsin. So once again, land availability, right? Do you have vehicle access? Do you have how close is a rail or major highway, interstate by chance? Grading considerations, right? Is it going to be flat? Is it going to be hilly? Population density. Now, this is a big one too. I ran a digester out in Rhode Island that was right off of an interstate, and there were homes behind it, and it became a bit of a pain because the locals, they could see it and they could see what we were doing. And we were also next to the landfill and next to an auto recycling plant that would take cars and basically grind them up. And so any smell that happened, we were the new kid on the block at the time, and they loved to point fingers and, hey, look, look what they're doing. And yeah, that can be tough. Sometimes you want to put it out in the open, but conversely, I had a facility that I worked with that was out in the middle of Colorado, miles away from any homes. I think there was like 2 or 3 homes within a 5-mile radius. And they got shut down for odor complaints permanently because they weren't handling their food waste correctly and doing proper odor control management. And it cost them the project. So those are all things you got to keep in mind. But then also to a point of population, you still need to make sure you're running it properly. Utility availability, as we discussed earlier, right? 3-phase power. Maybe you need some natural gas to power some equipment on site. And then environmental and permitting, right? So is there a lake, pond, river, streams nearby, wetlands that it could impact, distance to groundwater, nutrient loading, any floodplains, county zoning. I know one of the facilities I worked with years ago had one of their systems would feed manure up from the farms. It was a 3-farm system that would feed to a central digester, and they didn't have proximity switches on their knife gate valves. One of them didn't open. The PLC had no clue it didn't open because there was no proximity switch to stop it. They turned down a positive displacement pump, burst the line, and ended up putting, I think it was 80,000 gallons of manure right into the local creek that went right through town. So those are things that you got to keep in mind, right? Because you don't want to be on the wrong side of that. It's not fun. And it's not something that any of us want to do, right? But it's even more of a pain when it happens. So next slide, please. So then here I'm just going to look through a couple pieces of equipment commonly used for nutrient recovery. So this would be post-digestion. And they were also talked about on that slide deck that we put together earlier, talking about the different total solids contents and what you would use to treat it for manure, for example. So screw press is commonly used to get the solids out. post digestion. And basically, what they do, as you can see from that image on the left, it's basically a plug at the end of an auger that's spinning with a mesh screen around it. And as that plug builds pressure, it pushes the liquid out of the screen, and then the solids are able to slowly come out through the plug. A very simple piece of machinery. It doesn't take a lot of maintenance. So it's very, very popular at dairies and things like that. But I've even seen them in uses. A big one is a Huber press, big maker. They actually use it for the orange industry down in Florida for moving rinds and pulp and things like that. There's a side hill screen, another very simple piece of equipment that's used for initial separation of digestate, especially if it's thinner, because it literally just flows over the top. There's like almost like a weir up there, and you can see it's not a mesh. It looks like a stainless steel panel. It flows over that, then hits the screen, and then the liquid is able to run through where the solids build up on the screen until they eventually fall off into a separate. And then for really low TS, you've got ultrafiltration. You can see there on the right, sometimes paired with reverse osmosis as well to really get it down to like almost like a drinking water. Next slide, please. Next would be a horizontal decanter. A common one is a centrisis. I know a couple dairies that use these. They have a spinning bowl that basically uses centrifugal forces to pull the solids out, as you can see there at the front end of the bowl. And then at the end, you've got more of the liquid and things are going to come out and be pulled out. And actually, if you go to the next slide, you'll see a picture of one that's in use. And this was at a dairy. This was taking digestate right from the tanks, and it would separate out, and you'd have the fiber you can see kind of going down to a blue conveyor that takes it up and into a drum dryer so it can be dried, and then it was used for bedding for the cows that they call fiber bedding very commonly. And then you'll see as you go from right to left across the centrisis unit, you'll see another tube coming down. That tube is for the effluent coming out of it, so the liquid content. So just showing you one in use. Next slide, please. Next, we have like a belt filter press. That's common for lower solids, where it basically flows over a belt. It's spread out across it, and then it's pressed against the belt. The belt is also a filter. So as it's pushing against the belt, the liquid is pushing through, is going through the belt and draining out the bottom, and then the solids come out after going through a cacophony of rollers to be discharged or disposed of. These are very common. Actually, I'll see these in wastewater treatment plants for the sludge to be dewatered further. Next is a dissolved air flotation system, or a DAF. The one on the top there is a brand new unit that was delivered for installation. Usually what they do is you'll hit it with a polymer and a coagulant so you can bring the solids out of the material and kind of float them, and then you'll have a white water pump that aerates the basin, and you can see that in the bottom right as that's floating the solids, and they're building up on the beach. And then there's a scraper that comes along and pushes them into a solids bin, whereas the effluent's allowed to flow underneath and over a small weir and flow out. So common pieces of equipment used in nutrient recovery and dealing with digestate. Next slide. With this, I'm going to hand it over to Scott. You there, Scott?
I'm trying to turn on my camera here.
Oh,
All right. Maybe while Scott's doing that, I got two people who sent me questions that maybe you can
oh,
address.
yeah, sure.
The first one was you mentioned food waste and you were changing substrates. What do you do to handle the variation in materials and keeping your digester as consistent as you can?
That's where it becomes very important to do analysis on the substrates, right? You want to be doing TS, VS, total solids, volatile solids, and by using those, sometimes you can also do a BMP, a biomethane potential. It'll tell you how much gas it's going to make, but really the TS, VS is where it's going to come in handy for doing your OLR, your organic loading rate. And that's what's going to really matter day to day, because if you get something right that's really diluted out, there's not a lot of energy there. So in that HRT, it's going to hurt you because it's going to be a lot of water, and water doesn't make you gas. Like, you need it for pumpability, but it's not making you anything. Or as conversely, say you get, hey, our freezers went down, we have tons of material to send you. Yeah, that can be tricky now too. Is that okay? Now I have this high dense energy material, and I have a lot of it. How am I going to put it in? This is where it becomes really, really important to put holding, some sort of feed tank storage, something so that you don't have to just force feed it whatever you get that day. Now, like a typical dairy system, they'll usually design it for how many cows they have. And then that way you kind of have a consistent daily amount of manure that you're seeing. But yeah, food waste is tricky. Food waste is really, really tough. And the best thing you can do is have storage, have contracts in place so that you can say, hey, I was only told I was getting X amount a day. You have to, run it by me and I have to approve it if I can take it. Maybe sometimes if there's somewhere you can store it on site to take it and feed it in at a later date or slowly meter it in. And that's just all stuff that has to be taken into account when you design one of these plants. And let me tell you, after running a food waste facility, they're not easy. It can be really, really tricky. I think one of the best ones I ever saw was a co-digestion facility that would take in 51% manure, 49% food waste, and it was perfect because the manure gave a nice solid feedstock base. They had plenty of storage on site for all the food waste, and they were able to just meter it in with the manure. And yeah, to this day is one of the best running food waste facilities I've ever seen.
Perfect. Thank you. And then the second question was actually about odor. You mentioned a place where you had odor challenges. What are some of the things you've done to help with odor control?
Well, it was funny because for that facility, we weren't even fully operational. But the odor was visual. People saw stuff come in to get dropped off. They saw food waste coming because we were still filling our digesters. We hadn't got to the point where we were really running. And yeah, it can be very visual. Another part is just making sure that you take care of vector control as well. But it's like don't leave food waste out on the pad. Don't leave, if you cover your tanks, make sure that your depackaging system is indoors. Have it under HVAC negative control so that if anybody opens those doors, it's sucking in air, it's not pushing out. Have a proper odor control system, something like a biofilter is very, very common. I've used those at many sites. Just something so that you can get that clean, you can get that air cleaned and stripped of that odor, 'cause especially with food waste, it can be very, very odorous. And that's actually what that facility I talked about was in the middle of Colorado that I wouldn't have thought they had any problems. There, it turned out all of their feed storage tanks before they went into the digesters, usually you can hook them up to some kind of air control system. They had them venting to atmosphere. And so anytime they fed in, it pushed out more. Another facility I was at, it was in the middle of Charlotte, North Carolina. They didn't have a pump to offload fog trucks. So what they would do is they'd let the truck come in, they'd hook up to the bottom of their holding tank for their feed tank, and they'd just let the tanker push in with its own built pump system. And what it would do is it would overwhelm the PRV on the tank and it would vent out the top and they'd have instantaneous odor complaints.
Mm.
So to deal with that, what they ended up doing, and they had negative air on the vent for these tanks, but it was just so much that it would overpower that pull. So what we did is we redesigned their system to have a pump to pull off the trucks at a consistent, slower rate that then wouldn't overpower the HVAC system. So it really it's a case by case situation, but biggest ones, it's visual. It shouldn't be, but it is visual. So keep that in mind. And two, just be a good steward. Don't keep your site clean and design your system to handle these odors because they will be there. I hope that's an answer
I
for
appreciate that.
that.
Yeah, I think that
I
was
know it's a
great.
broad topic.
It is. Location, location, location to start with matters a lot.
Yes, that was the one that I was at in Rhode Island. I, I wanted nothing more to pick up the facility and move it 20 miles out of town.
Hmm.
It would have made a lot of things easier. But so yeah, just things to keep in mind.
All right. Thanks, Ben. With that, we'll hand it over to Scott. I did see we have another question, but we'll try and answer that one at the end.
Oh, perfect. Thank you.
Yeah, so we're just going to roll through a couple of different options for using biogas. We'll go from what I'll call historic traditional uses to more recent uses here. So the first one we're going to talk about is direct use. That's where effectively you're taking biogas, you're removing sulfur, removing moisture, and then using it for like a boiler system. This is very common in the meatpacking plant industry. So a lot of those types of facilities have built-in wastewater treatment systems with anaerobic lagoons where they're producing biogas. So fairly common. Also, can be used to heat barns at farms. So this is one that's been around for a long time in terms of end use, and it generally tends to have pretty low O&M costs. From an incentive perspective, there's pretty limited incentives here other than offsetting your costs. Combined heat and power, electricity is another widely used application for biogas. Historically, renewable electricity prices were if we go back 15 years ago, were a lot higher than they are today. So a lot of biogas plants were built under the guise of making renewable electricity. Um, Nowadays, those facilities are competing with solar and wind, which tend to be a little bit cheaper. But one thing that I will say here is as we're talking about concepts like time-matched renewable electricity, under the guise of the Inflation Reduction Act for producing hydrogen, for example, biogas plants are great. They're effectively batteries, right? If you build in redundancy with your engines, effectively, you'll be able to run 24/7. So one of the upsides of biogas to electricity, they do tend to be fairly high from an O&M perspective. As you can see, the engine's got a lot of replaceable components, so they do need to be tended to. The last use case would be renewable natural gas. I would say that's the predominant market that we discuss in today's world. There's a fair amount of existing incentives out there through the Renewable Fuel Standard, which is a federal credit market. And then also there's a couple of different state credit markets that also add an additional monetary credit for the use of renewable natural gas as a transportation fuel. Um, Here's just a couple of pictures of landfill gas projects that we've worked on. Um, Getting into gas treatment, sulfur removal is a big deal. It's an acid phase gas. It likes to eat things like metal. So there's a couple of different ways in which you can remove sulfur. For smaller sites, you're typically looking at a fixed bed media type system. So that can be an iron oxide based media, activated carbon, pretty common. You do that when the gas is saturated because the water helps with the H2S removal process. Another, let's say, more sophisticated approach would be a regenerative system where you're using chemicals to scrub out the sulfur. This is done, at large refineries. It's also done at decent sized dairies and wastewater plants where you have high enough H2S concentrations to justify their installation. Obviously, when you're getting ready to develop a project, you want to look at kind of the life cycle economics, and it will help inform your decision on which direction you want to go. Here's a good table that Guild developed a couple of years ago that kind of shows flow and concentration and where you might want to be at for different flows and concentrations with respect to treatment systems. For VOCs, now we don't talk about that a ton within the agricultural space. Generally tend to be pretty low in terms of volatile organic compounds when we're talking about strictly agricultural digester facilities. However, if you're looking at co-digestion, wastewater treatment, or landfill gas, VOCs and siloxanes are present. And so it's important to understand the concentrations that you might run into because again, similar to sulfur, there's different types of systems out there. Fixed media is, I would say, the most common. When you get into large landfills or food waste facilities, you're going to start looking at temperature swing absorption units. So that's what the computer shot here is of essentially a TSA system where we've got two vessels that are actively removing VOCs and one that's being regenerated for future use. So just some considerations with gas treatment. From a market perspective, renewable natural gas is effectively a drop-in fuel. It has the same qualities as natural gas, so it's used widely in the transportation fuel market now through the RFS and through state low carbon fuel standards. There are avenues for it to be used in refining and production of additional fuels. And then, from a decarb perspective, manufacturers are interested in using it as well as power generation and gas utilities. So I've always thought this was an interesting slide. As we know today, the largest market is the transportation fuel market for renewable natural gas. And this slide kind of projects out effectively, use cases for renewable natural gas. And we can see here that 60% of the projected use case is going to come through voluntary markets, which, would be outside of your renewable fuel standard, or your LCFS compliance programs. What's driving that is really at the state level, a number of different programs. So you have different states with different RNG programs. I would say no one is very similar. So, for example, in California, they have a mandate that 12% of the overall gas supply being provided by investor-owned utilities is renewable natural gas by 2030, which is a pretty high bar. Um, in states like Missouri, they have programs where utilities can use financially prudent investments to obtain cost recovery for projects. So we're working on one right now in Missouri where the utilities is essentially going to be developing a rate case for the project when it's complete. So this is just kind of good smattering of where we see RNG policies. I would say there's lots of states where their baits are highlighted now. This might be an older graphic, whereas they, weren't a couple of years ago. So I see this as helping to grow the market. Going back to the renewable fuel standard or transportation fuel markets. So the renewable fuel standard, the set rule was finalized in July of 23. That expanded the use for RNG effectively to be able to use biogas to make other renewable fuels. And I think overall, what we see with the original framework of the RFS is the goal was about 16 billion gallons a year of cellulosic biofuels. As you guys can see from the table in the upper right-hand corner, we're nowhere close to that. So there's quite a bit of runway. And to Ben's earlier point about future projects and potential projects, there's opportunities within this framework to continue to grow in the transportation sector. I will say one of the limiting factors, however, is the ability to offtake the gas, right? So you have to have a CNG truck typically to run on renewable natural gas to be able to generate these credits. And we've seen widespread adoption in California to the point where effectively 99% of the trash trucks in the state of California run on CNG, which is good, but we need more use cases. So I think that's where biointermediates will have a home and help to expand the market. So this is another graphic that talks through our renewable natural gas projections over the next 30 years or so. And essentially, this analysis shows that the supply in 2050 is going to effectively be 2/3 of what is going to be the demand. So I would say that's good for growth. Obviously, these projects rely on some incentives and some higher pricing than traditional natural gas, but compelling. And to my earlier point, RNG can be used for a number of different things. So you can use it to make hydrogen. When we're talking about purifying biogas, there's CO2 that is stripped off as a byproduct, and folks are starting to look at that for different use cases. So e-fuels would be a large one that people are starting to look at now. Exporting RNG is becoming more of a relevant topic these days. There are some countries where book and claim, which is the same premise that we use within the United States for claiming credits, is allowed. EU is not there yet, and I don't know that they will ever be, but there are several countries where RNG can be exported, which helps. Sustainable aviation fuel, RNG can be used as an input, and then to Ben's earlier point about nutrient recovery, we're producing organic fertilizers. Those fertilizers have a high value, especially with the commodity value of fertilizers being where they're at right now. So, there's a lot of different things that we can use to help these projects make economic sense. From a development perspective, when you look at an RNG project, you have a number of different parties, right? So you have feedstock. You have somebody that's signed on to generally take care of the facility in terms of operations and maintenance. From a business perspective, you need all of your standard administrative services, so insurance, accounting, etc. And you need an energy off taker. So these projects generally tend to happen. And it depends on what the end use is. Some folks play the spot market and the transportation fuel. Others will prefer to sign up for a long-term fixed offtake of the gas. And with that, the attributes can either be bundled or decoupled and sold. And then byproducts, i.e., digestate, um, can also be sold. One thing that I will say is, with digestate specifically, um, it's not always a revenue source. So if you've got a food waste project or even a co-digestion project where you're dealing with, some contaminated food waste, it may end up being a cost for you. So not always a revenue source. Just some tips for partnering with third-party project developers. You want to have a concept plan that's fairly well defined before you get too far down the path. So, understand how the location and land ownership is going to work. Oftentimes with agricultural facilities, that means you're taking out potential cropland that is providing revenue to an existing farm. So you need to understand the pros and cons. Understanding the biogas quality and production rates is very important. If you're trying to tie into a pipeline that can't take it year round, then you're going to have to continue to look further away, which will impact your cost. And then gas quality is also really important, right? So, for example, in the state of Michigan, if you're tying into any gas utility within the state of Michigan, not FERC related, but a gas utility, the quality of that gas, the oxygen content of that gas needs to be 10 parts per million or less, which means that you need another piece of equipment that costs you at least $1 million plus operational costs. So it's important to think through all of those things. And I guess point is it's good to have a preliminary financial evaluation before you get too far. This is a conceptual slide that just kind of shows project development timelines. I will say these timelines are not fixed in stone, but it's effectively a good list of different milestones that you want to meet at different stages and different levels of investment along the way, right? So we typically will execute projects in what we call stage gates or different phases, just commensurate with the level of investment, basically. So you're not starting in right away on construction drawings on day one. You need to do some feasibility work to make sure that there's a project there. So with that, I guess I'll open it up to questions.
Perfect. Thank you so much, Scott. We do have a couple questions. One was, what biofilter do you recommend for odor control, or what manufacturers have you worked with and had success with before?
To be honest, the few that I've worked with were all made in-house. They're a pretty simple system where you're pulling the air in and you're basically putting it through a bed of wood chips. So yeah, sadly I don't have a direct manufacturer for that, but it is a pretty common design. So
Yeah.
hopefully that helps.
Yeah. And I would say in the wastewater industry, odor control is very commonplace. So there's a number of different industrial odor control vendors that exist within the market today, primarily to manage odor of our human waste at wastewater plants, but those are translatable into these facilities.
Perfect. And I'm going to plug Iowa State at this point just a little bit. We have a tool called AMPAT, Air Management Practices Assessment Tool, which walks through one of the practices on there is biofilters, and it's biofilters for putting on a pig barn. But since it's wood chip bioreactors, I'm guessing they're pretty similar, and those are set up to help farms build them. Another one isn't a question I got today, Scott, but it's one that we've gotten in the past on this webinar series, and it was from ethanol plants thinking about using anaerobic digesters for heat in their corn ethanol production. So they need heat to run their process, and they were forward thinking for 45Z. Is there potential there? Have you seen projects like that? Is there that more
Yes.
that we need to study?
Yeah, absolutely. I mean, there's a couple of different benefits, right? So um, there's the biointermediates that we talked about earlier, right? So that's using biogas for production of other fuels. There's also when you get into carbon intensity benefits of ethanol production. We've worked on a project that's been operational for years in South Dakota where landfill direct direct use pipeline to an ethanol facility, right? It helps lower the carbon intensity of the ethanol being provided and increases the marketability in states where you have low carbon fuel standards.
Beautiful. And it looks like we had a few questions roll in. Uh, can you comment at all on the price of electricity generation compared to a biogas upgrader? And then maybe what that means for farms not on a pipeline or near a pipeline. How do we think about making access more equitable to different farms?
Ben, you or me?
I can start. So that's something that back in 2015 or prior to 2015, it was really popular to do electricity generation. That was huge. I had a lot of sites that were doing CHPs, generating, putting on the grid. They were getting PPAs for a very, very friendly payoff for that. Well, when those PPAs expired, a lot of electricity utilities went, hey, we don't want to do that anymore. So we're just going to offer you what we offer everybody else. And it would turn those projects upside down. Now, that's why a lot of groups went to RNG, but then that becomes difficult too, because if you're not near somewhere to inject, you're going to have to do a virtual pipeline, which now you have a tanker, you have other things involved. You have to pressurize it enough to go in that tanker. You have to scrub it on the site. So that's very complicated and doesn't always make it work. And that's why actually in recent years I've been seeing some turn back to CHPs because they are great for small farms that are kind of out and isolated if they can get a good enough deal for their energy. So it's really just, and this is something that I found across this whole industry. It's very, very case by case.
Yep.
And the small farms are tough, but things are getting better as technology progresses. Scott?
Yeah, and I'd say just from a rule of thumb type of capital cost perspective, right? I think that was part of the question. RNG facilities typically tend to be 2 to 3x what an electricity project is going to cost you, right? So electricity projects are cheaper, but again, the commodity value is not necessarily as tangible. I think time-matched renewable electricity is a theme that will help small farm economics in the future. And I think, the concept of embodied carbon, which we didn't really talk about too much today, but producing a negative CI score electricity, I think there's going to be a place in the market for that in the future as well. So
I agree with that. And I think we're all hopeful that such a market will develop and it should develop. And then the last question I think is both maybe the easiest one and the toughest one. Ty asked, we have been cautioned that biodigestion of our spice herb material is not recommended because the cellulosic material is too hard to break down. Is BMP testing the key or another analytical test for feasibility? And do you agree? And is there reason manure works is because the cow's digestion system has somehow done the work of breaking down uh, the feed material essentially for us?
Oh, 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 I want this one. I want this one. This is kind of my bread and butter. I've had this on a lot of projects. So BMP, yeah, BMP is a great test to see about what it can break down. Basically, what you're doing right, you'll ask for TSVS, total solids, volatile solids. So that's telling you, TS is telling you how much water was in the sample. So that's going to remove that. And then your VS is a percentage of your TS. So if I have 10 gallons and it's 10% TS, that means 10 of those gallons are solids. And then if it's 50% VS, then 5 of those 10 gallons is volatile organic compounds. Now, this is where it gets tricky, though, and this is why a BMP is important. If I go and do the VS test, right, it burns everything organic. So those fiber, the cellulosic materials, things like that, all get destroyed. But a digester doesn't have a way to digest cellulosic material. So that doesn't work for a digester, right? So that's where a BMP comes in because you're actually digesting it and measuring the gas it makes, and you're seeing in a digesting environment how much of that sample is actually going to break down. Now, I'd say probably if you have a high cellulosic material, it's probably not going to have too much energy. There could be some other things in the mix that might break down and make some energy. BMT test is going to take about a month plus. There's plenty of labs that do it. Michigan State University, Oshkosh does it, and there's a number of other national labs as well that you can get in. I don't know if I just mentioned it, $700 to $1,000 in that price range for those tests. That's a great way to see feasibility. It's probably not going to have the most gas production, but not knowing your material directly, I can't answer that. But now the manure part of it, though, is that this is where there's a lot of confusion. That fiber that's going through that cellulose material that's going through the cow is not breaking down in the digester. It's giving a home for the bacteria and the microorganisms that are making the methane and doing the work, but it's not breaking down. It comes out the other side, and that's actually a big thing that you use a screw press for, to pull those fibers back out, then dry them, and you can use them for bedding for the cows. So when I say fiber bedding, that's what you're actually using. So yeah, anything cellulosic, a digester can't eat that. It goes, I mean, we don't have termites in the tanks, we have nothing that can eat that material. So that's a really tricky part too, because that's somewhere where, like I was telling you about the open lot manure collection, right? A lot of the stuff that the digester is eating is soluble. It's the sugars and things. It's things that get broken down in in nature by heat and wind and other things that go on. So the longer that manure sits out there open to the elements, a lot of that stuff starts to be eaten away by the environment, because right, nature abhors a discontinuity. So it's unequal, so it's going to start breaking it down until there's nothing left, and then it's just it's cellulosic and things that bacteria couldn't eat. And that's what happens is a lot of sites, their manure will be in a situation where it'll sit out for way too long. The value's almost gone. Yeah, it's still a pile of manure. Yeah, you can still touch it and feel it and all that. I wouldn't recommend it, but it's not going to make you the energy in a digester anymore, because that material has been eaten. And yeah, some of the BMP samples that we pulled at some of those dairies out in Utah were, I think the one VS came out to like 59%. And once you get below 50, that's it. The rest of that's all cellulosic material that, yeah, it'll burn and yeah, it'll make energy, but not in a digester. So that's why a BMP test is so important. Um, and also when doing your sampling, I mean, obviously for you, it sounds like you'll have a pretty consistent, but like say you were at a dairy, make sure that you're getting it from where it would be going into your digester and not just following the cow around collecting as it comes out. So it's got to be realistic. So I hope that answered your question, Ty.
Perfect. And I think that was a great answer. And just to follow up on that, manure is digestible, but if you take the feed stuff, corn silage that you feed a cow and digest that, you would get more gas production per volume. The cow has extracted much of the usable energy.
Yes.
It's just we've paid for it with another resource. All right, a couple things as we finish up today. Can I get you to stop sharing your screen for just a second?
Yep.
First of all, thank you so much to both Ben and Scott for joining us today and sharing a fantastic presentation. I know I really appreciated it, and especially seeing of some of their diagrams about when you choose different digestion systems. And then I have to do my closing notes here. Uh, in terms of fresh manure, especially from some feedlots, one of our future speakers, not next month, but the following, will be talking about roller compacted concrete and how that might make obtaining manure from different feedlots a little bit easier, because that certainly is a huge challenge. I know I was sent a manure sample once from an open lot in the Western US, and it got here, and I was like, it's 40% sand of these solids. Who would want this? So next month, we're going to be meeting on April 8th, and Jake Wilsey is going to talk through some does more frequent digester utilization influence carbon intensity scoring of manure systems, and how does effluent storage and its use impact project economics, which Ben and Scott pointed out, making sure we have a plan for that digestate is extremely important. You only have to do this once for this year, or we only ask you to do this once for this year. But if you're willing, please fill out our voluntary demographic survey. Melissa will drop a link in the chat right there, so it's a little easier if you don't want to scan it with your phone. This is part of a Horizon 2 grant from the USDA Partnership for Climate Smart Commodities, and get a slightly different name maybe than Climate Smart, but that's where we're at today, and that's led by Raceline Alternative Energy. But we're really about promoting anaerobic digestion and the opportunities it has. USDA asked me to put my funding acknowledgement there, so you can see right there is the federal award number. And then finally, if you or a friend you know missed the webinar today, we will make it available on our YouTube channel, and we will be sharing a PDF copy of some of the slides. It might not be quite ready this week, but hopefully in the near future we'll have that up for you. With that, thank you so much for everyone for joining us today, and thank you so much for a fantastic presentation. It was great seeing you all.
Thank you.
Thank you.
Thanks, Ben and Scott.